on the left, a huge explosion of radioactive material.
The effects of this were predicted to hit the Earth on Wednesday and Thursday.
Satellite communications, power grids, even air travel could be affected.
Recently, the Sun experienced an extraordinary solar storm, which resulted in the formation of a massive fire cannon. The massive outburst of charged plasma was animated in stunning detail by NASA's Solar Dynamics Observatory. In April of 2022, charged particles from the Sun finally reached Earth, and on August 9, following a solar flare, they did so again. They smashed at 600 kilometers a second into the Earth's magnetosphere, creating auroras. The northern lights were visible from the United States to Canada. Scientists, though, think that our good fortune was simply a fluke this time around. Instead of a spectacular celestial show, it could have been disastrous had a more intense solar storm hit Earth. Solar storms have previously demonstrated their devastating potential at least twice in the past. The possibility of another strong burst of plasma from our Sun is increasing now that its activity is nearing its peak once again. Concerns have been raised about the Sun's current activity and the potential consequences of the next major solar storm for life on Earth. Make sure to stay until the end to know all there is about the unusual activity happening on the Sun right now. The solar wind is a continuous stream of protons and electrons from the corona, the Sun's outermost atmosphere. In a plasma state, these charged particles travel across the solar system at rates ranging from roughly 250 miles, 400 kilometers per second, to 500 miles, 800 kilometers per second. When solar wind reaches Earth, it sends a flurry of charged particles into the magnetosphere and along Earth's magnetic field lines, causing them to collide and travel to the poles. The interaction of these particles with the Earth's atmosphere can result in spectacular aurora displays over the polar regions. The existence of the solar wind was first proposed by pioneering astrophysicist Eugene Parker. According to the University of Chicago, Parker was working as an assistant professor in 1957 when he recognized the Sun's superheated corona should, in theory, release charged particles at high speeds. This superheating is one of the most enigmatic characteristics of the Sun's activity, and solar physicists are still puzzled as to why the Sun's atmosphere is hotter than its surface. Parker's theory said that plasma in the Sun's corona is constantly heated, with temperatures in this region reaching a scorching 3.5 million degrees Fahrenheit, 2 million degrees Celsius. When the plasma becomes too hot for the Sun's gravity to hold it, it is propelled into space as solar wind, carrying the Sun's magnetic field with it. His theory was widely criticized at the time, Parker recalled in 2018. The first reviewer on the paper said, "Well, I would suggest that Parker go to the library and read up on the subject before he tries to write a paper about it, because this is utter nonsense." Support for this theory was eventually provided by astrophysicist Subrahmanyan Chandrasekhar, who ultimately became the namesake of NASA's Chandra X-ray Observatory. Despite his dislike for the particle idea, Chandrasekhar accepted Parker's theory because he saw no flaws in Parker's calculations, according to the University of Chicago. Then, in 1962, solar wind particles were detected by NASA's Mariner 2 spacecraft as it headed to Venus. In addition to the regular streams of solar wind, the Sun occasionally expels large amounts of those charged particles all at once. These events, known as coronal mass ejections, CMEs, can cause geomagnetic storms in the Earth's atmosphere, which are connected with the spectacular aurora displays. But they can also disrupt power grids, telephone networks, and satellites orbiting the globe. But how far does the solar wind blow? The solar wind blows through the solar system far beyond Pluto's orbit, generating a gigantic bubble known as the Heliosphere. According to NASA, the Heliosphere moves with the Sun and is fashioned like a long windsock. According to an ESA statement, the Heliosphere's nearest boundary is around 100 AU from the Sun. 1 AU, or astronomical unit, is the average distance between Earth and the Sun. It is approximately 93 million miles, 150 million kilometers. The heliosphere works as a protective shield, shielding us from cosmic rays, which are energetic particles that can harm living cells. Cosmic rays are created outside of our solar system and travel at almost the speed of light. These high-energy atom fragments would constantly bombard Earth if we didn't have our protective bubble. Though solar wind always flows from the Sun, its qualities such as density and speed change over the Sun's 11-year cycle of activity. Sunspot numbers, radiation levels, and ejected material ebb and flow from a solar maximum to a solar minimum during this cycle. These changes have an impact on the solar wind's attributes, such as the strength of its magnetic field, the speed at which it moves, temperature, and density. At Earth, the average continuous solar wind speed is roughly 190 miles, 300 kilometers per second. During a flyby of Venus by Mariner 2, the spacecraft not only detected the presence of solar wind, but also identified two separate streams of solar wind, one rapid and one slow. According to NASA, the slow stream traveled at roughly 215 miles per hour, while the rapid stream raced by at twice that speed. The source of the fast stream of solar wind was discovered in 1973 using X-ray photos of the Sun's corona collected by Skylab. Coronal holes, cooler regions of the Sun with an open magnetic field line structure that allows solar wind to escape with relative ease, are the culprits for the fast solar winds. During coronal mass ejections, CME occurrences, unusually rapid solar winds can be generated. Wind speeds can reach more than 600 miles per second during CMEs. How have solar flares affected Earth in the past, and would the Sun's peak activity in 2023 pose a threat to our home planet? In spite of the vast distance between the Sun and our planet, coronal mass ejections can get to the Earth in as little as 2 to 6 days. When it comes to the highest energy particles, though, the same distance can be traversed in just 2 minutes. Only a small fraction of these particles actually makes it through the atmosphere and smash with gas molecules, causing the atoms to emit light. The rest are deflected to the poles by the planet's magnetic field. However, every once in a while, the Sun will start having tremendously powerful flares with an energy level of around 10 to the 25 joules. That's nearly the same as millions of hydrogen bombs with a yield of 100 megaton. As a result of a solar storm, plasma travels across space at twice the speed it does under normal conditions. It pelts Earth's magnetic field with such intensity that charged particles can pierce it or drastically deform it. This causes geomagnetic storms to occur, the most powerful of which can trigger a wide variety of catastrophes. In 1859, British astronomer Richard Carrington witnessed a massive solar flare on September 2nd. A powerful geomagnetic storm, one of the largest ever recorded, hit Earth 18 hours later. On that day, several telegraph poles were burned across Europe and North America, rendering the telegraph networks inoperable. The northern lights were visible from nearly every location on Earth. Humanity bounced back from the disaster rather rapidly, but back then our society relied much less on electricity. In March 1989, the whole Canadian province of Quebec went dark for 12 hours when another large solar storm hit Earth, leaving millions of people without electricity. This was generated by a solar flare, but it wasn't a particularly strong one. An impending disaster awaits Earth if the next solar explosion rivals the force of the Carrington event, the most violent geomagnetic storm ever observed. Researchers formerly believed that solar storms of this scale only occurred once every century. Solar flare patterns were then studied by researchers at the University of Warwick and the British Antarctic Survey. It turned out that intense magnetic storms occur far more frequently than anyone had imagined. The Sun's activity tends to repeat itself every 11 years. At its peak, the Sun exhibits unusually furious activity, and charged particles are directed one after the other towards the Earth. Scientists have compiled a comprehensive study of the history of the Earth's magnetic field fluctuations. The findings backed up the theory that the strongest solar explosions coincide with the strongest spikes in geomagnetic activity. The most threatening catastrophes for Earth were separated into two categories by the research team: strong magnetic superstorms and extremely destructive megastorms. In the former case, it happens around once every 3 years. For some whose well-being depends on the weather, these changes can be devastating. However, these problems rarely result in catastrophic technical breakdowns. Megastorms are much rarer. Only 6 such occurrences have been documented by scientists during the past 150 years. Therefore, solar storms hit Earth roughly once every quarter century, and there have been no major storms in the last 2 decades. Scientists predict that the next one will occur in the near future. A potentially damaging explosion occurred on the Sun in 2012, but luckily for Earth, the solar wind was blowing in the opposite direction. During periods of high solar activity, vivid auroras can be seen, including a rare type known as Steve, strong thermal emission velocity enhancement. Steve was visible as far south as southern Pennsylvania during the August 2022 geomagnetic storm, appearing as purple or white ribbons of light. Although scientists do not truly understand Steve, they are concerned that it may have devastating effects if it coincided with a megastorm. A megastorm combined with Steve might have serious consequences for the power grid, communication networks, and satellites. The ocean floor cables that connect houses to the internet may also be disrupted, perhaps resulting in a global internet outage lasting several months. The damage is expected to cost billions, if not trillions of dollars. If such a massive solar wind had hit Earth in 2012, several countries might still be fighting to recover. Natural calamities such as droughts, earthquakes, floods, and tsunamis are frequently produced by solar storms. Scientists have linked increasing periods of solar activity to greater seismic activity on Earth, with the 2004 9.1 magnitude earthquake in Indonesia being one example. This natural disaster killed about 283,000 people and displaced over 1 million others. Early warning systems are required to reduce the impact of solar storms. The Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, are two spacecraft that are now monitoring the Sun, which is critical for comprehending odd events on the star. Recent research, however, has demonstrated that significant geomagnetic storms can impact Earth even when the Sun is quiet, disrupting the 11-year activity cycle. A study of ancient ice samples revealed an unprecedentedly violent solar storm that slammed Earth 9,200 years ago. This means that potentially catastrophic solar storms can erupt at any time, which is why many countries emphasize the necessity of accurate space weather forecasts. In conclusion, the Sun's activity can have significant effects on Earth, including strong geomagnetic storms and rare megastorms. These events can cause harm to people and disrupt communication networks and the power grid. The next major solar storm is expected to occur in the coming years, and scientists are keeping a close eye on the Sun's activity to better understand and prepare for its potential impact on Earth. Now let's hear your thoughts about a mega solar storm hitting our planet in the comments down below.